So again, welcome. This is the Field Data Collection Using Smartphones and Lasers webcast, hosted by Laser Technology and GeoSpatial Experts. My name is Paul Atkins. I'm the Marcom Manager here at Laser Technology. Derek?
Yeah, my name is Derek Rash. I'm the Senior Product Manager here, also at Laser Technology. I work in the Professional Measurement Division, where we focus on the GIS, utilities, construction, mining, and forestry markets. And we have Stephanie with us.
Hi there, I'm Stephanie Giard, and I'm the Marketing Director at GeoSpatial Experts.
Great. And just to let everyone know just a little bit about laser technology and where we came from, we kind of got our start in the early 90s and did a really cool project for NASA. It was a proximity laser that was designed for space docking missions, so we're pretty proud of that. We're also responsible for the very first recreational rangefinder ever to hit the market. We did this in partnership with Bushnell Optics, and we're still active today in developing the most popular line of recreational rangefinders designed for both golfing and hunting. And over here on the right, you're seeing a photo of the very first reflectorless handheld total station. It's also being integrated with GPS. So we've really come a long way, of course, on the size, but the capabilities really, we're the first to put it all together and been in laser measurement for quite some time now. We're also an Esri business partner. Stephanie?
Excellent. So at GeoSpatial Experts, we created our mobile solution, GeoJot Plus, that you're going to hear about today, in 2011. But we've been in the business of GPS field data collection for much longer. Since 2001, we've been the leader in photo-based GPS data collection, and here on the screen are just a few examples of the thousands of customers we have worldwide. And like LTI, we are business partners with Esri and also Trimble. So GeoSpatial Experts and LTI have a network of resellers around the globe. Here on this screen, we've displayed the common resellers that carry both the LTI TruPulse lasers and our GeoJot field data collection system. But that's enough about us. You came here to learn about using smartphones and lasers for field measurements in the utilities industry. We're going to focus on joint use pole audits, but we'll also briefly cover other uses like right-of-way vegetation management and proof of performance here today. So you have the small handheld LTI lasers that allow you to capture pole and attachment heights as well as spans between poles without lugging around clumsy height sticks or measuring wheels. You can also easily capture the location of remote assets on private property or inaccessible sites that are hard or impossible to reach. The GeoJot app from GeoSpatial Experts runs on your smartphones and tablets and allows you to collect photos and digitally fill out forms to collect the data you need without pens and paper and clipboards and all those kind of headaches. The height, span, and offset data from the LTI lasers is Bluetoothed into your data collection form on the app. And then once you've gotten all that data, then the photos and all that data are transmitted from your smartphone via the cloud back to your office, where you process it through our desktop app to create Esri Geo databases, Google Earth maps, reports, pretty much anything you need. So LTI lasers coupled with the GeoJot Plus app can be used to collect the co-location data that you require both quickly and accurately. It's simple for anybody to use, so either employees or contractors can easily be trained. The inspectors can stand in one location and collect the data that they need for each pole. The solution eliminates most of the manual data entry errors. Inspectors can review their data in the field to avoid extra trips back to sites to collect missing or bad data. Then the data is automatically transferred to the office via the cloud. And all of this saves time at headquarters as well because you're entering the data digitally and then transferring it via the cloud. There's no more transcribing illegible handwritten notes back in the office.
So another thing we've identified using lasers and smartphones and the GeoJot software is also just to increase the safety. You've got to collect the data. There could be areas that have rough terrain or just unsafe locations like Stephanie talked about, or if you have to collect that data on private property that you cannot get to or that you don't want to get to, such as like the pit bull effect here. So you can stand in one safe location and using the non-contact laser rangefinder and the smartphone and app, you're able to collect that data needed. So it also minimizes the use of safety gear, so you don't have to be close to the poles or touching any of the conductor lines or getting that close. So standing back in a safe location and collecting the data is what we've also identified using this solution.
All right. Well, everyone we talked to today is working long hours and faced with a lot of complex problems on any given day. The GeoJot Plus TruPulse laser solution helps to simplify your data collection efforts. So this includes reducing the number of devices inspectors are bringing into the field. You can quickly train inspectors in just minutes. You can transfer the GeoJot app licenses between people, so between contractors and employees. You can also transfer it easily between all of your different devices. And in the end, you're able to share the information through reports, Google Earth Maps, ArcGIS shapefiles, and geodatabases, and also input for your backend database.
Another application we see using the lasers and smartphone and the GeoJot app is within vegetation management, especially the right-of-way. You've got the NERC requirement, which is where the vegetation needs to be away from the conductor and towers for certain distances. This is all about that public safety and fire concerns with the NERC requirement. So with the laser rangefinder, you're able to measure the width of a right-of-way, capture those distances. You can also capture and measure tree heights for those hazardous trees, and just the distance to the conductor from the vegetation. This is all, again, collected using the laser rangefinder and then collected on the GeoJot app.
Hey, Derek, before you jump into the next slide, we do have a question I want to go ahead and address. I think this would be more for Stephanie. One of the questions was, can it sync directly into a SDE database?
Sync directly into an SDE database. Well, it doesn't sync directly into the database. What it does is you process it, because we find that most people don't want to be inserting this data automatically without anybody looking at it before it's written into their database. So you push it through the desktop app where you can review the data, and then you can write it to a geodatabase. And we also have tools that I don't want to get into explaining right now, but that can help you just push it directly into your database. So, so we give people that step to be able to review it before it's pushed in, but then we have tools to make it really easy to push it wherever you need it to go.
Great, thanks.
Thanks, Stephanie. We also have a customer that's out in California that they use lasers and smartphones. They're basically doing wooden pole assets. They got to classify the poles, capture the height using the laser rangefinder, and they also are measuring the diameters of these wooden poles. So they're using another device of ours called the Criterion RD1000 that does diameter measurements. And they're capturing the diameter of the base of the pole, and also right underneath the cross arm. It's not so much for condemned poles or anything like that. It's more seeing about if they can add more joint usage on these poles. So they're using the laser rangefinder, the smartphone, and just capturing all the measurements we can for all this wooden pole asset application.
All right, proof of performance is another popular use for our solution. So it's really used on both sides of the equation. So we have contractors who are using it to get paid more quickly, and power companies that are using it for proof of performance before authorizing payments. So people are able to identify problems with any new attachment installations. They're able to find discrepancies between installation reports and actual poles installed, and also locate problem areas and deliver reports with maps and geolocated pictures for proof.
And this is just a small snapshot of all the many uses and other applications that we see a lot of our customers using this technology for. The telecom industry, of course, just even bridge surveys, disaster response projects, forestry applications, mining applications, and really the applications are just endless. Here you're seeing some samples of like just obstruction mapping, clearance values of out on a job site. Crane positioning is becoming a hot topic, just making sure you're within OSHA requirements. So anyway, this is just one of, many applications that are available and are being currently used today with both technologies.
So now we want to kind of dive into the actual use of the laser rangefinders. Basically, using the rangefinder, we're kind of eliminating those conventional tools, so eliminate the height sticks and the measuring wheels. As a lot of you can probably know or use these instruments, they only work really well in fair conditions and also flat and accessible terrain. The height sticks also require field calibrations and additional safety gear. So what we're doing is embracing the future. Like Paul talked about, is our reflectorless technology. Laser technology focuses on the pulse laser technology to measure distances. And we can measure to any type of surface, so we can measure right to that conductor, or the attachment points, and also poles at various distances. So there's no use, you do not have to have a second person with a reflector or a prism to capture these distances. Again, that's that reflectorless technology. All our laser rangefinders, the TruPulse models, have a height routine built inside. This is a simple 3-shot height routine. The first measurement we're going to do is get a horizontal distance measurement to the pole. You see here the horizontal distance is 66 feet. And then I'm going to do a base angle. Basically what we're doing here is just getting the angle or tilt angle of the instrument. So you don't have to have a clear line of sight to the base of the pole. Like you see, this is grass here in front of the wooden pole. What we're doing is just measuring the tilt angle of the instrument only, not measuring the distance. So you can kind of not guess, but see, look where that pole might be going to the ground and take that base angle. The next what you want to do is going to take your top angle. You can do it right there at that attachment point, and then the instrument is going to calculate that height routine or height measurement. What we can do now is we can actually capture the next 2 attachment points. Basically, we've already established our distance to the pole and that base angle. Now, with the simple press of the button, we're able to do the next attachment point and so forth, so we can capture 3 height measurements pretty quickly.
Hey, Derek, before you jump into this next slide, I do have a question that came through. Can you measure directly to the cable? Our main issue is the height of the middle of the span.
Yeah, that's one of our applications. What we do is we're able to measure right to those conductor lines at various distances. It's not like 1,000 feet, but I mean we can measure directly to that to get the height there. And we have a couple other routines of getting height to the midspan.
Okay, thanks.
Yeah. Another routine we have built on in our TruPulse models is called a missing line routine. It's basically taking a measurement between two different objects from a remote position. You're going to need to have a TruPulse 360, which has a compass built inside. So we get that slope distance, inclination, and now that azimuth value to the target. So from a remote position, I take a measurement to my first pole to the left, then I'll take a measurement to the right, the pole to the right. And with those measurements, we're able to calculate the distance between those 2 poles. We get that horizontal distance, slope distance, and even the vertical distance between shot 1 and shot 2. So it's a pretty powerful solution built inside. Another thing we can do with the laser rangefinders is using your smartphone. Smartphones have GPS, so you'll be able to get a GPS position. Now, using a TruPulse 360 that has that compass, so we're, again, getting that azimuth value, slope distance, and inclination values, we can measure to the distance, pole in the distance. And using the GeoJot software, the software is going to actually calculate a remote GPS position using those measurements given by the laser rangefinder.
And I just wanted to highlight some of the major advantages over the TruPulse laser versus some other units that are out there in the marketplace. They call them the all-in-ones. They kind of shove all these components into one unit. One of it is, just the lightweightness. I mean, you can see the middle picture there, and the compactness is huge. You can fit it in your vest pocket. It's certainly not very cumbersome at all to carry around. It's actually the size of a recreational rangefinder, but it does have all those professional measurement attributes that Derek mentioned. Over to the right, we're highlighting a true vector compass technology, and that's something Derek mentioned too in the 360 models. This is unlike anything else on the planet. It's the only all-in-one compass laser that can be calibrated in 8 simple steps. It takes less than 30 seconds, and actually get accurate azimuth measurements within 1 degree, no matter how or what angle you tilt that thing at. And then over to the left, just the viewing scope is huge. It's a 7 power optics on most of our lasers. You get a nice crystal clear field of view. You actually can see the target you're aiming at versus, relying on a screen and a camera, dealing with sun glare and that sort of thing. So just the targeting and aiming mechanism is just superior to anything else out there in the market. And then price point, price is certainly a big contributing factor. We're a fraction of the cost of a lot of these all-in-one units or even total stations.
All right. Well, I mentioned this earlier, but I think it's worth mentioning again. Not only is this solution easier for your field crews, but it's also easier for the staff back in the office who's receiving the data, because you're eliminating all those handwritten paper forms and people trying to decipher what somebody had written down and all the frustration that goes along with that. So this is the future. It is coming. I could bore you with statistics about the increase in smartphone sales by 2016, but I think everybody knows what's happening out there. People are or will be comfortable using smartphones. Many of our customers actually have their contractors using their own phones, so then they don't even have to have the capital expenditure for hardware or deal with issues around the bring your own device policies. A little bit more about the GeoJot app. I know this is a common question we get. What will it run on? It will run on Android smartphones and tablets, iPhones and iPads, as well as the higher accuracy Windows mobile handheld GPS units like the Trimbles and Junipers.
So all the measurement data that I was talking about, the height measurements, the missing line measurements that a TruPulse will give you, it's not stored on board of the TruPulse unit. So what we do is we download that information into GeoJot using Bluetooth. All our devices, all our TruPulse units integrate with the Android devices, and then our new TruPulse 200X version will laser rangefinder will work with iOS devices.
All right, we said we would try to keep this around 20 minutes. I think integrating a few questions in there while we're going, if we're probably going to run a little bit long, but we certainly don't have time to do a full demo. You can find technical videos going over how to use the app with a laser on the GeoSpatial Experts website, but right now I am going to go over and just highlight a few areas here. So this is the GeoJot app running on, I believe it's a Samsung Galaxy, and you click on the icon, and it takes you to the home screen. And the first thing we're going to do is we're going to hook up to the laser, and so we click on Settings, and then Advanced. And then third from the bottom there is Laser Connect. And then initially you'll see you're not connected to a laser. And so the next thing is that the app will scan for the nearby lasers, and then you go ahead and you'll select your laser. And then you are going to be connected, and you can see that information there that's coming from the laser directly into GeoJot. You can also, you'll notice there's an automatically connect option on this screen, and so you can select that, and then every time you start up the app, it will connect with your laser, and you're ready to go. So to actually collect your data, you have your start screen here, and you click on Forms. And we've already collected forms. I'm not going to go through form creation here. Once again, on the GeoSpatial Experts website, there are training videos. There are 5 to 10 minute training videos on specific things that you can do with the app. One of them is creating your forms. But so we've already created these forms, and we're going to go ahead and select the poll survey. And then you go to the camera screen. Let's say that I'm here and I need to get this poll, but I don't want to walk across the highway to the actual location of the poll. So what I'm going to do is I'm going to shoot it with the laser and capture the location safely from where I'm standing. So I shoot to the pole, and that offset distance appears on my screen in GeoJot Plus. It's pretty small print when you're looking at it here in this presentation, but it says 88 feet right above the GPS accuracy in the lower right-hand corner. All right, so I've taken my photo with the GPS and the offset location, and now it's time to fill out my form. So there are lots of items here, but what I'm going to do right now is I'm going to do the pole height, so I select pole height. And then for any of these items in the list, when I create my form, I can say that I'm going to use a drop-down and create the values, or I can type in, or here I'm going to use the laser. So I'm going to do a 3-point height routine with the laser. So I take the horizontal distance, the base angle, and the top angle. And then the laser computes the height, and GeoJot picks that up via Bluetooth. All right, so like I said, all these other items I can collect with drop-down lists or type-ins or even barcodes. And then when I've filled all of this data in, I hit done, and then I'm on to the next poll.
And Stephanie, before you jump into the cloud real quick, I just wanted to address a couple questions that come through. We have a question about, have these devices been tried or used on overhead transmission line assets? And it's giving an example of 138 kV voltage and higher. And I guess I'm not sure of that. I don't know if you guys can answer that question or not.
That's something I could get back to. I could get back to the participant about later. I'm not sure about that kind of those specifics.
Okay.
Okay. All right. Let's see here. So I was talking about you've filled in your data and you've hit done. And what happens is when you configure this beforehand, it takes about 2 minutes, and you can configure it to send up all of your data to the cloud automatically. A couple of questions that people have about this automatic data transfer is you can specify that to do it in Wi-Fi only, so you avoid the data overages. Also, we have a lot of people who are collecting the data in remote areas or areas where there's spotty cell phone coverage. And so if you've selected to have it automatically sent up to the cloud after you collect each poll, then the data is put into a queue, and as soon as you're back in coverage range, then all the photos and the data start going up to the cloud and back to your office. And then one other thing is when the data is being transferred via the cloud, there's also functionality that you can set up beforehand in configuration where you can rename and organize the photos automatically dynamically off of fields that you're filling in on your form. So let's say that you want to have all of the data that's coming from each of your inspectors go into a different folder. That can be done. Or all the polls that were marked as needing to be replaced. Those could all go into a specific folder, and so they can be organized like that. And also, when you're collecting your first photos, you don't think about it, but the renaming feature is also really powerful as well, because when you get into the thousands and tens of thousands of photos, having them named 0001 JPEG gets to be a problem. And so you can automatically rename and dynamically organize your photos as they're being put up into the cloud.
And then before you jump into the next slide here, I have a question. Can the forms dynamically show and hide fields? For example, we need fields for up to 10 different attachment heights on utility poles, but usually there are only 2 or 3 attachments. Having all the extra fields really clutters up the form. So is that a possibility in GeoJot?
That's something I can talk to the person offline about.
Okay.
Yeah. All right, so the next slide should be the desktop calculations. So Derek went over capturing all the heights and distances with the laser in the field, but there is another option. If you capture pole height in the field, you can calculate distances between attachments back in the office. So if you capture the photo of the pole along with the laser pole height in the field, and then you bring the data for review back in the office, you go into the photo editor and you calibrate the photo with that TruPulse height measurement. So here we're saying that it was 53.8, and then you go to the next screen, and you can make any other measurements between attachments because you've calibrated the photo with that overall height. And last but not least, importantly, GeoJot creates the output that you need, which includes ArcGIS shapefiles and geodatabases, output for relational databases and spreadsheets, Google Earth files, watermark photos, customizable reports, and web output.
Great. Just to recap, some of the major benefits that we touched points on today, both Stephanie and Derek mentioned, just this greater efficiency and accuracy, with the accuracy of the unit itself, the efficiency of being able to capture, measurements without, having to physically walk up to every single pole, and just the repeatability is huge too. So just, if obviously anybody's trained, different people can go out and use this equipment and show the same results. Derek mentioned about the increase of safety, simply just, not dealing with, again, private property, liabilities and aspects, and just be able to remove yourself from, high-profile traffic and that sort of thing is just huge. And just the fact that it is simple to learn and operate, and we're going to address some of this, as far as some training videos that we do have available that you can see and watch before you even purchase any of this equipment. But just because it is simple to learn and operate, I think the usability is huge because, we hear over and over companies implement these, new softwares and equipment, and when it's really cumbersome, it tends to get a lot of pushback from the field crew. So we really feel like this is a great solution for that. And we did address, just going from, all the way just, from the field data collection to the final reports, and that's really the whole value of this complete solution. It's not just one dimensional. It does definitely take you all the way from the field to the office. And this is just some next steps that we ask that you guys all do, and one of them being you could download a free trial version of GeoJot on your smartphone right away, and kind of poke around in it and see and check out the usability. There's also training videos that Stephanie mentioned, and these can be found on the GeoSpatial Experts website. Laser Technology also has TruPulse training videos. They're about 5 chapters, 20 minutes in total duration, so really anybody can sit and watch these videos and be up and running and be able to use that laser like a pro in less than 20 minutes. And, as far as next steps, too, we had some questions that come through, and they're asking about, common resellers. This is just a list of some of the resellers that GeoSpatial Experts and Laser Technology have in common. We will, have a survey at the end of this. If you are interested in us contacting you directly to get an on-site demo, we absolutely will turn that over to an authorized dealer and certainly get you taken care of. And last but certainly not least, I just wanted to address a couple other questions that are coming through, and then we'll display our contact information as well. One of the questions came through, Derek, about the TruPulse 200X. You mentioned it did communicate with the Apple devices. Does it also communicate with the Android?
Yes, the TruPulse 200X interfaces with Android, iOS, and Windows mobile devices. So it can connect with all those via Bluetooth.
Okay, great. We have another question. Oh, go ahead.
I was just going to say, I saw someone who asked me to spell the name of the app because they were having difficulty hearing the exact name. So it's GeoJot, which is GeoJot+.
Okay. There's another question that came through. Can this laser device be any use in the measurement of trees? And absolutely, this forestry is a huge application for us, and we have thousands of users worldwide that are using that. And there's some really great, filtered features, meaning you can shoot through dense brush using a reflector if need be. But absolutely, this is for certain can be used for measuring trees. Let's see what else we had here. Does the trial include desktop software?
Oh, that's a good question. Yes, it does. GeoJot is actually a full field data collection solution. So we have the app that you load onto your mobile devices. We also have a web-based app that allows you to manage all your users and deactivate users and activate new users. And then there's the desktop portion, which after you collect the data with your mobile app and it goes up via the cloud, comes back to your desktop app where you can actually review the data and make any changes that you need to make before you use that desktop app to generate all of your output.
Great. It's also asking about, does it use the phone GPS or an external device? So, and that's another good question that we often get. It's, by default, it will use the internal GPS of the phone. With our Android app, in order to increase the accuracy with that, we also have a GPS averaging feature that you can use in the phone. But if you want to connect to an external device, there are a few different things. So one is that the app will actually run on Windows Mobile 6.x handheld GPS devices. So a lot of the Trimble devices and Juniper devices, the app will actually run directly on the device. But also you can still use your phone and you can link externally to like an SX Blue or to a Trimble device or a Puck or whatever it is that you have. Great. That actually was a question we did have earlier about the SX Blue, so that does answer that, hopefully. They're also mentioning the SX Blue is decimeter accuracy, and I was interested in if the laser could integrate with our collection method. So, Derek, I believe that does communicate with the SX Blue GPS, correct?
Yes.
Oh,
yes,
running on the iPad. It's saying running on the iPad. So, I believe the only laser we have now is that 200X that communicates with the iOS and Android. Okay.
So I see another question here. It says, do I have to transfer data via the cloud? And the answer is no, you don't have to transfer data via the cloud. You can bring back your mobile device, and you can just hook it up to your computer and download off of your mobile device directly onto your computer to process it. You can also email the individual photos, but that's very time-consuming and tedious. But the other thing with transferring it up to the cloud is that what you're doing is just then pulling it back down onto your desktop and then doing all of your work on that. You don't have to keep it stored up in the cloud. The data goes where you want it to go. We just offer some different transfer options, but we don't force the data to stay in any one place.
Great. We do have a question about this being recorded, and yes, it absolutely will be recorded. We do have your information, and once recording gets rendered and will be posted on a website, we'll certainly push out an email and let you know when that will be available, and it's probably going to be about a week from today. So I think with that, there are some other questions that we can certainly address offline. It sounds like that we can do that. And then I just wanted to thank our guest speakers today, both Derek and Stephanie, for their time, and of course all the attendance and questions. This obviously seems to be a good topic and some high interest. So we will again do some follow-up. There's going to be a survey at the end of this. If you can answer those questions, that will definitely let us know how interested you are and how soon you'd like us to get in touch with you. So again, with that, I'd like to conclude this webcast, and thanks to everyone for joining.